All right. So, do you think that it will replace the shadow mapping in the future?
Yeah, I mean, I'm definitely confident that ray tracing will replace shadow mapping for four different reasons. One of them is shadow mapping is very constrained by the linear projection that you have. There are some things like rectilinear warp shadow maps, where basically through tessellation and all sorts of other things, but there's a whole bunch of hacks. You need to chop up the triangles. You can kind of squeeze certain parts of the shadow map and then expand others. Uh, but it's still rectilinear, so it's not like you can blow up a certain point and blow up another point without any repercussions because it's all kind of coupled together. I mean, if you blow up this point, then you can't shrink this point. The only way that if you expand this area here like this and like this, then this area here is gonna also like expand like this. So you might be able to shrink it like this, but then this area is depending on that. So rectilinear warps, they improve the distribution of pixels a lot, but it's not like a magic solution. There's also adaptive shadow maps where you render the scene, you figure out which pixels you can see, and then you build a bounding box of them in light space. So then you can crop your shadow map only to the bits that you actually could see with your camera, which is, I mean, it's really awesome if you're in a city or in a car, like I am right now, and the only thing you're seeing is basically the next wall over and the car, and you're not looking at the valley, um, you know, down in the distance. Uh, and that's great as long as your viewport is like that. But the moment you turn over to the valley and you can kind of see a little bit of everything, then that kind of this gain disappears. You can obviously combine adaptive shadow map with rectilinear warps, uh, but then that's two compute shaders. um, and then you can also combine that with cascaded shadow maps, where you can chop up the stuff into cascades. But still, there's a number of things which are going to present problems. So dueling Frosta is gonna present a problem. So when you've got a Frostum where all of the resolution from a camera is kind of concentrated in this little area, and then as your field of view grows bigger, then every single pixel is a little bit bigger in world space. And then if you've got your your light caster from the other direction, we're talking about an actual light, not the sun. The sun's rays are parallel. So if you've got like a really strong light, like let's say you wanted to have a searchlight in the game, right? Then the resolution of the shadow map is going to be all concentrated on near the light. So the texels of the shadow map are going to be really small in world space here, but really big here. And then if you've got dual and Frosta, well, basically what means is that you've got them set up against each other. So the very big shadow map texels are going to be where they need to be the smallest, which is where the texels that your camera sees are going to be very small as well. And the problem is that you've got a big shadow map texel and a small screen space texel. So that's dual link Frosta. And for example, cascading shadow map only solves that problem a little bit. Basically, it mitigates it, but to really mitigate it, you would need a lot of splits in the cascade, and that's kind of an issue. And I mean, cascaded shadow mapping is really expensive, so because you basically need to draw 4 times. You're not drawing everything 4 times, but you still need to do the culling, all of the stuff for all of the objects to kind of figure out which objects are going to be inside. And nowadays it's the bottleneck is not as much how many triangles or how many objects you're drawing, is mostly about how many times you swap the render target. Um, so yeah, I mean, cascaded shadow maps are really expensive, and then they're only used um, for uh, for big, very important lights, like sunlight and so on. Not really, for every single light. You're not going to use it for every single light. Yeah, I mean, you've got light perspective shadow maps, which is basically a warp to the shadow map, which gives you more resolution close to the viewing camera. But again, it can't it can't deal with dueling thruster. It can't help you there. Rectilinear warp shadow maps, that might help you a little bit by, if you've got dueling thruster, it's gonna basically grow the middle portion of the shadow map. So that's gonna help you there. And adaptive shadow maps are gonna help you as long as you don't have like a very wide field of view. So it's a little bit like occlusion. It's a little bit like occlusion culling. It works great for first-person shooter games, when you're in buildings and stuff. But when we're talking about, for example, Microsoft Flight Simulator, there's not going to be any occlusion. Because, I mean, if your point of view is high above ground, nothing occludes anything. Even like a mountain doesn't occlude another mountain. So that's kind of like an area where for all of the shadow mapping, you're going to be completely screwed. Because there's just, no way to reconcile it. And there's also like a lot of area and shadow maps that gets absolutely unused and is completely not necessary.
For example?
I mean, if you had like a shadow map, right? And you've got like a 2D view of the world, and then you were to draw the camera that's going to be viewing the world, right? Then if you were to kind of spread like rays away from that point where the camera is, and then kind of have like a second set of shadows, like 2D shadows in the shadow map, then all of the stuff that's shadowed, it doesn't have to be in the shadow map. Because the camera is not going to view it.
All right.
Really. Yeah. So, yeah, I mean, there's a there's a lot of stuff. Like if you were to draw the camera frustum, best case scenario, if you've got like a 90-degree field of view camera, is maybe 1/3 of your shadow map is not going to get used for anything. Because a view frustum, unless you've got dueling thruster or you've got frustums which are concentric, then yeah, I mean, you might have 100% usage. But if you're thinking about this is the sun and this is the camera, right? Then when you look down, it's going to be a triangle or like a trapezium. And that has to sit inside of a rectangular texture. So no matter which way you're going to twist the triangle, 30% or even more might not be used at all. Because basically it's outside the frustum. And then if then we add onto it stuff like, self-occlusion and so on, or for example, if your camera is against the wall, then, for example, or against the side of a building, then adaptive shadow mapping will give you a bounding box of all the stuff that the camera might see, but it's not going to be very tight. It's not going to be an oriented bounding box, or it's not going to be a convex hull. So the thing is like, even if you do use adaptive shadow mapping, there's still going to be like a lot of shadow map texels that even if you put, I don't know, floating point not a number in there, it's not going to affect your rendering at all. So I mean, a lot of work that you might do for a shadow map is going to be completely wasted. The memory, both the memory and the rasterization.